Okay, welcome everyone. Just got a small group today, but that's okay. So today we're going to kind of speed up the process. We've covered most of the Java basics, and there's a little bit more in object-oriented and collections, but we'll introduce those as we go along. So I'm having a little trouble. My computer thinks I'm the wrong user right now, and so I can't push my code. But what you'll want to do is go to github.com and then TestWizardry Java Core. And you can check out the code there. And that's going to be after this class for now because I couldn't get it right away. So we've got the basics of our greeting where we ask the name and so forth. So I'm going to show you. We've got the TestWizardry console, and I made a few changes to clean it up right before this class. So what I want to point out here is we've got this MagicUser class. And if you remember, I talked about how every wizard is a person, and every person has a name, a gender, and an age. There's a difference between a is a relationship and a has a relationship. A has a is composition. So let's go ahead. We'll look at person. Let me expand out here. So a person, if you remember, we added first name, last name, then we have gender and age. Now, yesterday we had gender as a string. What I want to do now is introduce how you can use one class to identify the type of another class. And so we have gender. Now, this is a construct that I haven't talked about before. It's called an Enum for enumeration. And the reason for doing that is largely historical because it doesn't do this in Java, but in C type languages, it does do this, that it creates a list of numbers that are associated to values. In this case, gender 1 would be male and female would be 2. In C programming language, for instance, you might do int, or you might do int male equals 1 and int female equals 2 in a very primitive low-level programming language. And then what you would do, you would say if, male wizard, right? And then if female, oops. And this is just kind of pseudocode. You can see it doesn't compile. So if you're male, you're a wizard, and if female, you're a witch. So you would do that in C, and that would work fine. And what that would do is that would save you, especially on early low-level systems, it would save you having all these characters doing a string comparison, which is kind of costly. A string comparison down at the lowest level goes and it checks every letter. Does this match? Does this match? Does this match? Does this match? And so forth. Whereas an integer comparison is very fast. Is this number 1? True, else it's false. So that's kind of what an enum is trying to accomplish, and also it organizes it. The other great thing is if you remember that in our code previously, and I'll pop that up to show you what we had yesterday in this TestWizardry console, right? We had ask gender, and we had this problem. I don't know that answer if they didn't type male or female and spell it correctly. So by having this enum type, it's both more efficient and more type safe in here, that ask gender is always going to return something, a value of gender, either male or female, spelled that way. And you can see we convert it to lowercase in case they capitalize it, because the programming language doesn't know whether a capital letter or a lower letter are the same thing. So that's one way. Now, the challenge with doing this is if the value is not male or female, it's going to throw an exception and let us know that. But we're not handling that right now, and that's okay. But let's go ahead and run through our slightly modified program, and I haven't done this yet, and see if it works because I'm literally coding this up right before class. We'll expand the console. It says, what is your name? I'll say my name is Aaron. Hello, Aaron. Are you male or female? I'll type male. You're a wizard. How old are you? I'm 11. And I don't have anything there yet. So that's the end of that program. So let's see. Let's finish implementing ask age. I guess that's all we get to. So let's run this again with the other scenarios where I try if I'm older than 11 or under 11. That should say that's too old or that's too young. And it'll give me one more chance to correct my age. So I'll run my program again. What is your name? I'm going to say my name is Jenny Weasley. Hello, Jenny Weasley. Are you male or female? I'm going to say female. You're a witch instead of you're a wizard. How old are you? Well, I think she's a year younger than Ron. So she's not going to be able to go to Hogwarts yet. That's too young to apply to Hogwarts. Are you sure that's really your age? And then how old are you really? It gives you a chance to enter one more time. She lies about her age, and then she gets to go. Now, that's as far as we're at now in this implementation. Now, what I want to do next is I want to take these values. I've separated this in. So I have my class, my TestWizardry console app or terminal app. When you think of a console game, you probably aren't thinking of a command line interface and an old school terminal. But that's what I labeled it. Maybe we'll port this to PlayStation or something like that someday. Anyway, so we're asking name, we're asking gender, and we're asking age. We've created these separate functions to do these multiple steps. And the primary value of it here is that it is making my code easier to understand. Now I can see everything that goes on in my entire main action loop in one small screen here in about 15 lines. So taking a look at this, what do we need to do? Now, what I've done is I'm going to take another step back, and we talked about how a wizard or a witch is a person, right? So let's hop back over here to our, oops, there we go. So looking at our source, I have a witch extends person. Now, person, and I can actually hit control or command click in Eclipse, and it will take me to person. So I can look at person, and I can look at witch in these separate tabs. A witch is a person, and that means that that I can set my age and my name and everything. A witch has everything that a person has. For instance, I'm doing a witch is by default a female. So when I create a witch as opposed to a wizard, I specify the gender as female. With wizard, I don't do that. Now, what I'm going to do instead is I'm going to say if you're a wizard, you're male. In the Harry Potter universe, a wizard is like wizard kind, like mankind. So when Haggard says, I see 3 young wizards or whatever here, referring to Harry, Ron, and Hermione, they're all wizards. But since we want to have a concrete class to represent a wizard or a witch, we also have a non-concrete class or an interface called MagicUser. And from yesterday, we talked about casting a spell and brewing a potion. And you can see these actually don't do anything right now, right? I had some text to cast a spell like Wingardium Leviosa or to brew a potion. And I quoted some Shakespeare, trouble, trouble, boil, bubble, whatever, cauldron, burn, and bubble. I need to read Macbeth again before I start trying to quote it. So a wizard. Now, a wizard extends person just like a witch. So a magic user going back over here, our player, and this is the word I was looking for and stumbling on yesterday. I was like, well, I don't want to do wizard. And because if it's a wizard or witch, I would like you or your or me or whatever. But it's the player. The player is a wizard or a witch, and that means they're a magic user. And a magic user is either a wizard or a witch. And a wizard or a witch are both people or persons. And this can get a bit convoluted, but just remember that it extends a person. A person is a class. It could be an abstract class, which I won't get into yet. But a person is a class. A person has attributes and can do things. A magic user is a category or an interface. And let's take a look at magic user right now. So we've got public interface magic user, and it just has these, definitions of functions. It doesn't actually know how to cast a spell or brew a potion. It just says that if you're a magic user, you can cast a spell or you can brew a potion. So, and you can see here that rather than having a spell be a string, a spell has a command or a name or whatever that you pronounce. The advantage of casting a spell is, well, if I cast a spell and it's Wingardium Leviosa, I think it's hard to pronounce in the movies too. That's all well and good, but what if I try and cast a spell and was it Ron says Wingardium Levioso or something like that, and it doesn't work. So by having an enumerated spell or specifying specifically that it's a spell I'm casting, it makes sure that the actual content is both correct, it's recognized as a spell, and also it's a type, right? If I cast a spell that says, how are you? Well, that's a string, and that would work for, for the parameters, right? If I try and cast a spell and instead of saying Wingardium Leviosa, I say, how are you? Well, that's not a spell at all. It shouldn't work, and it shouldn't know how to do that. So that's why we have this type spell. And a potion, likewise, if you brew a potion, well, if it's just a string, you can't brew a potion called how are you. A potion has two things. Number one, it has a list of ingredients, bat wings and eye of newt and whatever else is in a spell, mandrakes. I don't know how to make polyjuice or whatever, but we'll figure that out. And it also has directions or maybe instructions. And then you can look at this and you can say, well, a potion looks a lot like, when you describe it this way, it looks a lot like a recipe, right? If you want to make cookies, you have a list of ingredients and some instructions that tell you how to mix those ingredients together and to bake them at 375 degrees and to make sure your kids don't pinch all the chocolate chips out before you actually make the cookies and get a sick belly from eating too much cookie dough. I don't think that's in the official instructions, but every parent knows to do that from bitter experience. So a potion, we could say, if it were going forward and if we needed to model that in our system, we could say a potion extends a recipe. Just like a wizard extends a person. A wizard is a person. A potion is a magical recipe. But we're not going to worry about that right now. Now, what I wanted to do is point out something, and that is to introduce the idea of a constructor. Now, when we create an integer or whatever, I should just have like a plain file around for typing. I'll just call it scratch pad, right? And then I can I'll just call this function whatever. Most important thing in programming is coming up with good names. And now that I've gone off track, I forgot what I was going to do. Oh, I wanted to talk about constructors, right? When I create an integer, right? Say age, there's no constructor. I just pass in this literal integer, 11. Likewise with a string. Now a string is an object, but it's a very special object that has a lot of built-in things that no other object in Java can do. And that's probably because, because strings are probably the most commonly used type of object, right? So if I have my string and my name is Harry Potter, I pass in a string letter, literal. Now, with a string, I can also do string equals new string. And to avoid confusion, there we go. Now, what that will do is that will create a new empty string. But I can look at string, and let's see if it has the code here. Yeah, so there's a string, and you can pass another string. So I could make a new string. Oops. So let's go back to here. We'll call this another name. And we can pass in a string letter, literal, and create a new name. But we can also pass in an existing string and create that. So the first name is Harry Potter. The second name is also Harry Potter. And we can see that by running through the debugger. Let's go ahead. I'll double click here on line 7 on the gutter. It makes a little blue ball. What I want to do is introduce the debugger, which allows you to step through your code. In other words, to inspect your code while it's running. Oops. Well, that's not going to work. What I need to do is create an entry point, static void main string args. All right. Now I can debug, not run as, debug as Java application, this scratch pad. Let's switch. All right. So it goes through up to line 7. It highlights line 7 here in green, and it shows the line I'm on. And it shows these are the variables I know, right? That there's args. It's a string of 0 length. It gives it an ID. Strings all have IDs like that. And then it gives me an age, which is 11, because that was assigned on line 6. So we know age is 11. Now we're on line 7. We haven't yet executed line 7. So what we want to do to run line 7, because what we really want to do is see what the results of name on line 7 and another name is on line 8. So in the debugger, we have these other menu options up at the top. You can see the first one is to resume. That will just, I have this breakpoint which stopped execution at line 7. If I hit this green arrow with it's a mix between play and pause, it will resume the program and go ahead and finish, or it will go up to the next breakpoint. I have this red square, which is terminate or stop. No surprise there. It'll stop the debugger and it won't complete the program. Now I have these other ones, these little arrows, and they're hard to see, I know. But there's step into. Now I can step into this line. There's nothing really going on that I want to see. But if this called a function, I could see that. There's step over, which will mean essentially execute line 7 as it is. And then there's a few other options using step filters and whatnot. What I want to do is step over line 7. And you can see alternately, you can press F6 to do that. So if we look over here on our right-hand side, we've got our breakpoints here on line 7 that we did. We've got expressions. I don't have any expressions to check. But we also have variables. We have args, we have age. And now after running, executing line 7 and processing that, we have name and the value is Harry Potter. You can see because it's a string, it gives it another one of these IDs, which just lists. I won't go into that, but strings are unique. They keep track of each string. Now we still don't have another name. It says the value of the variable another name is not used. That's just a hint. But what we want to see is that name is Harry Potter, age is 11. We can see those same variable values over here by hovering over this, and that's useful if you've got a whole lot of values and you know what you care about is line 7, and you might have 50 variables over here on your side debug panel. All right, so what we want to do now is we want to step over, well, let's step into another name. Now, often when you step into, it's going to jump into the code. Here we see the string class like we saw when I first looked at it. Here's the string, create a new string that doesn't have anything. So it says set the value to the literal quote, quote. In other words, to an empty string with nothing in it. This one says, well, set the string to another string, the original that you passed in. So this is the actual source code for the Java lang string object. There's probably some optimization going on so that when it actually runs it, it's not as pretty. But this allows you to see what's going on. It's setting the value, it's setting the code, and the hash. Now the hash is a way that it compares strings more efficiently than going through every letter and comparing them, because that would be string intensive. So each string is unique, and it will, if you have two strings that are Harry Potter, they're going to have a matching hash. So we don't have to actually have to check each letter each time. It's like creating a checksum on a file to see that if it hasn't changed or not. All right, so now we're back in, we can close that string class. We're back in our Scratch pad. We have another name. What we're going to do is, well, I guess we were going to step over that or step into that. And oh, now it's gone from string to object, since string inherits object, or rather string extends object. Object is the base class for every object, for every class. Every class extends object implicitly. And right now we have the object constructor. It says public object, and it doesn't do anything, as you can see. So let's go ahead. We'll step in one more time, and you can see it actually goes out, and it's going to go back down. What we want to do is jump back to our code. Now we're back in here, and we're at another name. So far, what it's done is it's stepped out of new string and then new object, but it still hasn't assigned it yet. So what we'll do is we'll step into one more time, and it completes that term. And you can see on the right-hand side, we now have a variable. So essentially, what we did on the last step, we had done everything I highlighted here, new string. And then when I just did step into one more time, it then assigned it, did this expression. It took our new string, which is Harry Potter, as we can see, and it assigned it to another string called another name. And you can see, even though they both have the value Harry Potter, they have separate IDs. And that's how you debug. And I can either resume, there's nothing left in this program, or hit stop. So I could also, and I'll show you how I'm going to move my breakpoint up to line 11 and just show you one more time. So I'm going to hit debug again. And you can see it goes here. And right now we just have args, which is set right here in the entry point of main. And then rather than step into, which is this down, and you press F5, I'm going to hit step over. You can see age appears. If I hover over age, it shows 11. Step over again, name appears. And if I hover over, name is Harry Potter. It's Harry Potter over here too. And then if I step over again, now I have another name, which is also Harry Potter and Harry Potter over here on this side. All right, so that's a quick introduction to using the debugger. This isn't a very exciting example of that, but if you have variables that you think are getting set, if it's saying if you do this, then do that, do it this many times in a loop, that's where a lot of bugs come from, and that's where having the debugger that you can step through and make sure that you wrote everything the way you intended works. All right, so enough debugging. Let's go ahead and hit stop on the debugger, and then we're going to switch back to the open perspective, Java perspective instead of the debugger perspective. You can see rather than having the values and stuff, it goes back to my outline of my class. All right. Oops. There we go. Close that down. So we've got a potion, which is an object. We've got a spell, which is an object. We've got, I should have made a diagram for this, but the real ones that's going to help us is a wizard is a person. It extends person. A witch is also a person, and a witch and a wizard are both magic users, but MagicUser doesn't tell us what to do. It just tells us what we can do. So any wizard should be able to cast a spell, and you can see it's auto-generated stuff. It doesn't do anything, and so it returns false. We haven't written this. This is just auto-generated code. We can delete that stuff because the IDE helps out, right? Let me just go ahead and I will delete wizard to show you how the IDE can help with this, right? And then I'll go over to where did my scratch pad go? Right here, I just kicked off my headphones when I stepped on the cord. I'm going to create a wizard, and I'm going to call it player. And I want it to be a new wizard. Now, the first thing we see, it doesn't know what the wizard type is. So this is why I want to introduce you to packages. Now, a package, I mentioned yesterday, is like a namespace or a way to group your things. So you can see if we look over here on the package explorer on the left-hand side, we have the default package, which means no package. We have this scratch pad. And then we have the TestWizardry package, which includes witch, wizard, person, all that, right? If we look at witch, we can see that it's in package TestWizardry. So I can do two things. I can put my scratch pad in package TestWizardry, and it'll know how to find wizard. Oops. It's lowercase, I think. Let me look at my package explorer here. Oh, it's going to say it wants to move it to TestWizardry, but I don't want to. It's not actually relevant to my TestWizardry, so I want to keep it over here. But the other thing is, I guess wizard doesn't exist. I already deleted that. But if I say witch player equals new witch, let's just to keep this tricky or keep this clear. Hermione is a witch. And what I can do, this is going to help me. It says import witch, and it imports TestWizardry witch. What this is saying is find the package TestWizardry and import the class witch. Here under TestWizardry, we have witch. So it does that. Now the next thing we want to do is we also want to create wizard now, and I'm just going to recreate it now and show you how auto generates that. And we're going to create Harry equals new wizard. Now, wizard is underlined in red, and you can see wizard cannot be resolved to a type. It doesn't know what a wizard is, and it's not because we haven't imported it. It's because, well, I actually deleted that class, or I haven't created it yet, is another way to think of it. So I can click on this little light bulb, I guess it is, and it'll give me some hints about what I want to do. Do I want to create a class? Do I want to create a wizard, an interface, or an enum called wizard? We've looked at classes, we looked at interfaces, and we looked at enums. Well, I happen to know that I want a concrete example. So I want to create a class wizard. And so I can click on that and it will guide me through a wizard, um, a dialog here that says, where do I want to put it? Yes, I want it to be in my source main Java folder. And I'll explain that next in a minute. It says, what package do I want it to be in? Well, I want it to be in the TestWizardry package. And I can type that in here, or I can just hit browse and it will show me, oh, I have 3 packages available. The default package, none. TestWizardry or TestWizardry console, where I have the console that asks your name and stuff. So I can choose the package, TestWizardry, or type it. And it says, well, what superclass do I have? I can do the same way. I can browse and I can see we have object. I can also look for a person. And I have the TestWizardry person class. Okay. And then interfaces. What interfaces do I want? I can add an interface, and again, I can type it, or I can search for it. And we see here, I type MA, and it says MagicUser in the TestWizardry package is available to me. So I can click on that. So it's what this is saying, superclass, it's going to extend person and interface. It's going to implement MagicUser. I could also, if this was my main class, it could auto generate public static void main string array args. That gets old typing that. It could implement constructors from superclass, or write it, or inherited abstract methods. So that's what we're going to do. It could generate comments as well. But here we go. I click on finish, and now I have class wizard extends person implements MagicUser. And that's where these to-do auto-generated method stubs come from. I could have just as easily typed out everything myself. Well, not just as easily, slightly more difficult or moderately more difficult given my spelling and typing abilities. So that's how you can create a class that extends another class or implements another class, right? I could create a class wizard that implements MagicUser that doesn't extend person. It might also, it might extend, I don't know, reaching out to another mythology. It could, a wizard could be an elf too. Or maybe a person could be an elf or a human. But anyway, it doesn't necessarily have to extend person and implement. And it doesn't have to extend and implement. For instance, let's create one new class and call it Muggle. Now, a Muggle is a person. But a Muggle is not a MagicUser. So we don't have to implement brewPotion and castSpell, but a Muggle also has a name, an age, and a gender, and all that. Now, there are a few things that we want to do for a person, and for the sake of simplicity, I want to make sure that a person can't change their name or gender, right? You're born with one name and one gender. So when you create an object, you have that given name and gender. Now, some people have changed their names or whatever, but what we want to do is just to illustrate that this can't be done. So let's or that we can't do this in our code. Now I'm going to simplify this again and use just name instead of first name and last name. This is the principle of encapsulation. To use encapsulation, that means to both combine the data and the methods on that data that you can perform into one object. And it also includes something called data hiding. Now, we've been typing this word public over and over again, and it means just what you think it means. It means that it's public, that anyone can see it. If we create a class that's private, well, then no one else can see that class. There's 3 main options and one implicit one. there's public, there's private, and maybe age should be private, because some people don't want other people to know their age. So now I can go here. I'll go over to my scratch pad. And why doesn't wizard work? Okay, wizard does work. I just need to hit save. Right, I want to make a person. And I'm going to make him Aaron. Equals new person. And why can't I import that? Import person. Okay. And then I've got Aaron. I can set my name to Aaron. And I can do Aaron dot gender equals male. Gender dot male. That works. Now, if I were to do gender equals horse, that's not going to work. And you can see I have an error. Type mismatch cannot convert from string to gender. So I've got to go to, if I use the string male, well, that's also not going to work. What I could do is I could say gender value of male, and I'll show you that in the code later. And that will work. If I do gender value of horse, well, let's run this with male, and then we're going to print Aaron name, and then I'll put a space and then Aaron.gender. All right, so just to run this, I suppose I could use the debugger. There's an L in print line. So I'm going to run this. Aaron, male. Now, if I had my gender set as female, it would say Aaron, female, but then I'd probably spell my name Aaron like that. Now, this hypothetical Aaron with an E, or I guess we have an Aaron with an A-R-U-N. There's several ways to spell the name. Now, if I try and set the value to unicorn for gender, now this compiles. There's no squiggly underlines or red X's. It compiles, but then when it runs, it says exception, no enum constant TestWizardry.gender.unicorn, and we can see here that gender only has male and female. If I added unicorn here, then it would actually work. There you go. Aaron's a unicorn. And I can control click and go here and fix that. All right. So, but female Aaron doesn't want to share her name. Well, that's getting confusing. Let's change this back. I don't want to share my age because I'm very insecure about it. And you can see age doesn't exist, but it does exist. It's just private. So how can I set my age if it's private? Well, this is where we get an accessor method, right? Accessor are sometimes called getters and setters. So I can create a function called public string, or wait, not string, int, because it's going to return an integer. And by convention in Java, we call it get age, using the convention of lowercase first letter, each additional word is capitalized. And get age doesn't take any arguments. There's no parameters to pass to get age. But what I want to do is I just want to return age. Now this works. It's private. So when I'm writing code in the person class, I can access age. When I'm outside the person class, I cannot access their age unless they give me a way to do that, unless they allow me to get their age. So now I can go over here and I can say Aaron dot, well, I can't set the age yet. So I go back over, no, not to gender, to, let me see, person. So I would create another function that allows me to set the age. And this would be public again, instead of private. Void means it doesn't return anything. And I would do set age. And this get and set are conventions used in Java. And all sorts of tools will actually look for a function called getAge and a function called setAge, and then they will know how to set these private variables. And this is a good practice for encapsulation or data hiding in Java. So how would we set our age? Well, first we need to pass in a parameter of our age. So we want an integer, we'll call it age. Now, this doesn't make sense, age equals age, because, well, we have a variable that's local to this function. So this parameter or argument to set age is available throughout the age block. This integer age is available throughout the entire person block. So we have a conflict here. How do we resolve that? Well, in Java, what you do is there's a keyword called this, and we do this dot age. So this refers to this instance of a person. So for this person, set this age to the age that's in this local block. I hope that makes sense to everyone. And so now we have get age and set age. And we can go back over here and I can do Aaron. And now I call a function set age, and I'm going to stick with 11. Now, because the type of age is an integer, if over here I try and set my age to, if I set my age to unicorn, well, that's not a valid age, and my compiler will complain about that. This is one of the advantages of having a compiled language like Java versus an interpreted language like JavaScript. JavaScript doesn't have static typing, and it doesn't compile. What it says is, oh, you passed a string, I think you need a string. You passed an integer, or you're working with integers, I'm going to assume that this string is an integer, and it will cast a string to an integer, or vice versa, that sort of thing. And we saw something like that when it was working with printing numbers, right? When system out print line takes a number, it implicitly converts it to a string unless it performs that expression on the integer first, or unless you cast it to an integer. So set age, now this function set age will only take an integer, and that adds type safety, because say someone writes their age and they spell it out, and we don't know how to interpret ELEVEN to the numeral 11. We could either write code that knows how to do that, or we could reject it and say, please enter a number, a numeral, whatever. So that's a way of adding type safety and information hiding. And now I can also say, and I'm just adding that that quote space quote, just to put a space in between our symbols. Because if I don't, then I'll do Aaron. Yeah, get age, or wait, Aaron dot get age. Oh, I've got an extra A in Aaron. I don't know how to spell my own name. I run this, and Aaron male 11. So that's why I add space between them. All right, so that's what we've got. We've got just a few more minutes. So what we want to do is we want to do the same thing for name, and actually let's leave name public, but we also want to make gender private. And one reason we want to do that is because we only want to be able to set it once when we create it. So public void set gender, and then it takes a gender, and I can do this dot gender equals gender. And then, well, let's consistently put my get above my set. Some people do it one way, some do another. Set get gender. Now it's not a void, it is a gender. It's getting a gender. Return this dot gender. Well, I don't need this because there's no ambiguity about where it's coming from. And so I'm going to remove set gender and show you the next thing I wanted to, which is constructors. Now we touched briefly looking through the debugger how it called the string constructor. What we want to do is we want to create a constructor for person. And I do that by giving it the same name as the class. So I'm creating a function called person in the class called person. So when I type new person, it calls this function public person. Now there's an implicit constructor in every class. And that implicit constructor, if you remember for object, when we stepped through that source code, the implicit constructor looks like this. It doesn't do anything. It just creates an instance of this class as an object. So we can have an implicit constructor without even typing it. But what we want is we want to say when you create a person, you need at least two things. We're going to go for all three. We want to have a name, and we want to have a gender, and we want to have an age. Now, a person has all three of these values. So what we want to do is this dot name equals name, this dot gender equals gender, and this dot age equals age. Now, a person can't be created unless they have all three of these attributes. These are concrete attributes. Everyone has a name, everyone has a gender, and everyone has an age. If you don't have these three things, you're not a person. You might be a tree or a rock or a spell. A spell might have a name. I said command, right? Let's change that. Spell to have a name. A spell has a name, but a spell doesn't have an age, and a spell doesn't have a gender. That's why a spell is different from a person. Let's see, what have I got wrong here? Oh, now you can see what I do. When I create a person, what I have to do is I have to pass in these three values. I can pass in Aaron, male, and 11. And here what I can do is I can actually, let's see. I wanted to show one more thing. Oh, it doesn't give me a hint for doing that. But what I can do is I can import static gender.star. That's not going to work. Okay. I'll figure that out later. So I'm going to set male. So a person, in order to create a person, you have to have these three things, at least for the model that this program is creating. Now, a person also has 2 hands and 2 feet, at least most of the time. But those aren't things we need to know for this application, so we're not going to model them in this application. And that's an important thing to realize, that while you may create a class, you don't want to try and create more than you need at any one time. In other words, keep it simple. And then there's another acronym called YAGNI. You aren't going to need it. Don't add something unless you need it. Now, if you've noticed up here, which in Wizard, when I changed person, they've got these little red X's up here. Now it says class wizard extends person implements MagicUser, and it says implicit superconstructor person is undefined. If you define an explicit constructor like I did here for person, then the implicit constructor goes away. I could have both. I could have public person that does nothing. And remember, the white space doesn't matter. Now you can see that went away for wizard. But actually, I want to enforce this rule for now. And I'll show you why in a minute. So we've got get gender, but we don't have set gender. We've got get age and set age. What we also want to do is we want to have, name is public still, so we don't need accessors for that. And that's just for variety. A good practice is to have all your properties private and have accessor methods or functions for that. So you can see here which extends person. Now we have this super. Super is kind of like this. This refers to this object. Super refers to the parent class or the super class, the class it extends. Now, person would be the super of which, the parent. I don't know why they choose super instead of parent or some other term. But there's no person constructor with no arguments. So what we want to do is we want to fulfill that requirement. If you're a person and a which is a person, you have a name. You always have a name. And you have a gender. Now a which, we know that a which is always a female. But a which is always going to have an age, so we have an integer age. So now to create a which, or if you wanted to create a female, that would be the same. You would then create it, and then you would call this the parent constructor. Now again, there's an implicit super constructor, but when you delete the implicit parent class's constructor, then you need to also call the new one. Now we don't just call name and age, because person also expects gender. So we will pass our default in. So now we've done some simplification. To create a person, we need to know their name, their gender, and their age. But to create a which, well, we already know their gender, so we only need to pass their name and age in. But then when we instantiate or create an instance of a person, because that also requires the third parameter, gender, then we pass that in. So that's how we apply that for which, and we would do the same thing for wizard. And I would create the function, the constructor, public wizard, string name, int age. And then I would call super name, gender, male, age. All right, so that satisfies wizard. Let's go back to our scratch pad here, and then we'll close up. So now, rather than setting age and name and that, what I need to do is for a which, to create Hermione, I need to pass in her name. And I need to pass in her age, which is 11. And then likewise for the wizard, age 11. And now it all succeeds. Now, one last thing I'll show, and that is that you can print an object. So if I print Hermione, oops, I can go ahead and run this program. Oh, let's cancel that. Where are my errors? In Muggle. Muggle also extends person. So we need to go ahead and borrow from here, Muggle. I forgot I created that. Now, Muggle is a non-magic user, so they don't implement any magical abilities like casting spells. All right. So we can go back over here to our scratch pad. We can run it. And you can see what it printed was TestWizardry which at 3C whatever. Let's debug this and see what happens. Well, I forgot to set a breakpoint. I'll set it right here. And then I'll debug. Switch to debug perspective. All right, so I have Hermione, I have Harry. Let's expand. You see this little triangle arrow? I expand that. I see Hermione has age 11. She has gender, a gender, and I can expand that. And the name of the gender happens to be female. The ordinal happens to be 1. And I'll show you that in a minute. And then her name is Hermione Granger. So why, when I print out Hermione, does it just have that weird output of, well, let's go ahead and resume and step through TestWizardry, which at 3.3, whatever. Well, this is the ID of the object, and this is the default. The base object has a method called toString, right? I wanted to go ahead and step through that. So we'll step over, and then it creates Aaron, and then we'll step into this print line. So it says print line string value of X. So what is the string value of? Well, we're going to step into that, and it goes into the string class, and it says return object or object toString. We're going to step into that. And then here in the object, the base class of all objects, it says return get class dot get name dot at dot integer 2-hex string of the hash code. So not the ID, the hash code. That's what that weird code is. We hit resume. So this is the integer value of the hash code. You can see here the class is TestWizardry.which. The at symbol, it's literally just like I was doing, adding a space. They're adding an at symbol, and then this hash code, an integer value of that hash code. So that's what it's printing. But we don't want it to do that. We want it to print out something a little more interesting. So for which, what we're going to do is we're going to create a toString method, and it returns a string. It's public, toString. And what we want to do is, this is optional, but it's always a good idea to put 2 R's and override. So I'm overriding the base class's toString method. This method must return a string, so we want to return a string. And what we want to do is we want to return name plus is a, and then plus age plus, age plus, I keep getting that backwards. It's hardwired, is a age year old plus, and then what I want to do is I want to say this dot get class dot get, instead of get name, what I want to do is I want to get simple name. And this will be the last thing we do on this one. So let's go ahead and look at this. Now age, it says this person age is not visible because it's in person. So I'm going to do one other thing. I'm going to introduce you to private means it can only be used in this class, but protected means it can be used in this class and in subclasses. So by age being protected in person, now it is visible inside the subclass of which. Now, so there's private, where no one can see it outside the class. There's public, where anyone can see it, like name. And then there's protected, where this class or any of its subclasses can be seen. There's one other accessor attribute that I want to point out, and that's that if I don't have any public, private, or protected, then it is called the default access or package private. What that means is that anything in my package, so anything in TestWizardry can access it, but anything outside of my package cannot access it. So that's the default, and it's usually a bad practice to use the default, but I like to use it for explaining and simplifying things. So which has this toString method that it overrides. And you can see it returns a string representation of the object. So now the last thing I'll do is, oh, I need to go to my scratch pad. So I have Hermione is a new witch, and I'm going to print out Hermione. And so when I run this, it says Hermione Granger is now it probably should say an 11-year-old witch, but no one taught this computer grammar. So that's how you create a toString method, and you can override a method in someone else. For instance, with which we could override set age or something like that to do something. I can't think of an example off the top of my head, but I know we've run a little bit over on time. So I'm going to stop there. And what I'll do is I will send out a message on Monday. Well, I'll send out the code. I'll post it in the Slack channel as well to access the GitHub repository, which has all of these objects and our TestWizardry console. And then what I'll do, I think what I'll do going forward is I will have, rather than a scratch pad, I'll say, this is today's lesson, things that are not going permanently into our repository, but I'll still check in a scratch pad like thing. So this would be like lesson 5 scratch pad, which would show the things that I do outside the main group. That way I can execute things for demonstration without changing and editing the game flow. All right, thanks again, everyone. We'll talk to you on Monday, where we will continue implementing the game further. And I hope you were able to grasp the object-oriented principles I wanted to stress today. All right, goodbye.